Okay, so now let's do some examples, or some more examples of u substitutions. So here's what we have. So let's do the first one. So we've got to look for a function that the derivative of the function can be grouped with the differential, dx in this case. So I notice that if I take the derivative of this thing, it's going to be 6x, which is right here. And I can group the 6x with this. Now, I am not going to make u equal to 3x squared because I'm going to run into problems. Because I've got this constant here. Now, it doesn't hurt to add the constant to my u substitution because once I take the derivative of u, it goes away. And I still end up with 6x. So it never hurts to include a constant in your u substitution. In fact, in a lot of ways, it always helps. So, now, let's do u is equal to 3x squared plus 4. So that in u du equals 6x dx. And so now my u substitution becomes this. My integral will become u to the 4th du, which I can easily integrate. And so that's going to become 1/5 u to the 5th plus c. And now I have to substitute in for u. What was u? 3x squared plus 4. So now this becomes 1/5 times 3x squared plus 4 to the 5th power. And I'm done. That's it. Oh, hold on. Don't forget your plus c. It's an indefinite integral. You must always have a constant of integration. Okay? So don't ever drop the plus c if it's an indefinite integral. Okay, so now let's do this one. Okay, so notice that I've got a z outside here and I've got a z squared. So if I integrate z squared, I'm going to get z. Okay, so let's do, now again, I've got this constant here. So let's just make u equal to z squared minus 5. So then du is going to equal 2z dz. Now, I've got this 2 here and I don't have a 2 anywhere. Okay? Well, I've got to substitute in for z dz. Well, what can I do? I can just divide both sides by 2 and I get 1/2 or du divided by 2, or I can just say 1/2 du. So now this is going to be my substitution. So now what happens? I'm going to get what? The integral of the square root of u, and then instead of z dz, I'm going to have 1/2 du. Well, I'm going to pull the 1/2 out, and this becomes 1/2 times the integral of the square root of u du. Now, this I'm going to write as a power, right? So it's 1/2 u to the 1/2 du. Now I'm just going to use the power rule for integrals, and what do I get? I get 1/2 times what? Well, increase the power by 1, so I get 3/2, multiply by the reciprocal, so that's going to be 2/3, times u to the 3/2 plus c. And so now this becomes what? Well, this cancels with this, and I get u to the 3/2 over 3 plus c. And now I'm going to substitute back in z squared minus 5. So then this becomes z squared minus 5 all raised to the 3/2 power divided by 3 plus c. And that's my final answer. Now let's look at this one. Here, now remember what I said before is I want this differential dt is in the numerator. Okay, You can have it out to the side. Sometimes they put it in the numerator, but remember, I want my du to be able to be grouped with dt. So anytime I have a rational expression, my du has to be in the numerator, okay? Because if I was to do u is equal to sine, my du would be cosine, but cosine is in the denominator, so it wouldn't work. So I'm going to make u, in this case, cosine t, which would mean my du is going to equal negative sine t dt. And so again, I don't have a negative out here, but that's okay. I can just multiply both sides by -1. And now I've got sine t dt right here is equal to negative du. So guess what? Now I can rewrite my integral as negative du over u cubed. Or, if you want to write it this way, you can also write it this way, as -1 over u cubed du. Or you can write it as negative outside, so it's -1, and then you get u to the -3rd power du. Now you can use the power rule for integrals. So this is going to equal what? I'm going to increase the power by 1, which would make it -2, divide by -2, that's going to cancel with this negative, and I'm going to get u to the -2nd power over 2 plus c, which is then equal to 1 over 2 u squared plus c, which then equals 1 over 2 times what? What's u? U is cosine. So then this is going to be cosine squared t plus c. And that's it. Have a great day.